Good afternoon, students. Today we are going to explain how to solve trigonometric equations. We're going to explain this question on page 234, question 8. This is the question I asked you to do previously. It says solve the following equations. And a lot of you don't know how to do this, right? I'm going to show you. So I just want to direct you to one part of the reading. This reading is on page 228. This diagram is very important for many of you, right? So there are several different ways you can approach this, but this is definitely one of the most common ways. It's called CAST, C-A-S-T, right? Some people use this diagram to help them remember when sine, cosine, tangent are positive and when they are negative. A means all positive in this quadrant, right? Okay, so to explain what this means, okay, so I'll just snip a picture of this. Okay. So A means all positive in this quadrant. That means in the first quadrant, from 0 degree to 90 degree, all functions are positive. So sine is positive, cosine theta is positive, tangent theta is positive. S means sine positive. So in the second quadrant, from 90 degree to 180 degrees, it's only sine is positive, right? So that means sine positive, cosine negative, tangent negative. T means only tangent is positive between 180 and 270. Right, so that means sine theta is negative, cosine theta is negative, tangent theta is positive. And lastly, C from 270 to 360 degrees. Then it's only cosine is positive. So sine theta is negative, cosine theta is positive, tangent theta is negative. This is only one way how you remember it. There is an alternative way. Okay, so this is what we mean by alternative way, right? So what's the alternative way? The alternative way is the way that I personally prefer is look at each function. We have to decide. We have to know their period. I hope you know what period means. If you don't know, go to the textbook and look for the definition of period. Right? So the period means, okay, so I'll just do a search. Period. Okay, so previous. Okay, so it's also periodic with a period 360. So you just do the same thing and then you can get the same information. So it repeats itself. Period pretty much means repeat the graph. Right, so this sine graph repeats itself in 360 degrees. Cosine graph repeats itself in 360 degrees. Tangent graph, it repeats itself in 180 degrees. Guys, I also would like you to remind you, oftentimes you are very familiar with the degree system, but you also need to know the radian system. So you should know this is 2 pi. This is 2 pi. This is pi. And you should also be able to plot the graph proficiently. Right? So sine graph, just giving you an idea, it looks like this. Right? So this is 0, this is 2 pi. You see it repeats itself every 2 pi because after 2 pi, that's itself again. Right? And cosine graph. Cosine graph looks like this. It's also repeating 2 pi, but it's starting from a different point. Right, so this is a 1. And I start 0, this is 2 pi. Again, let me show you it. Wait, sorry. Sorry, that's not 2 pi. This is 2 pi. Right? Okay, let me show you. It also repeats after 2 pi, so this is what it looks like. Right, and then tangent graph is a little bit special. Right, so it repeats every 180 degrees, every pi. So it looks like this. And this is a half pi. This is a negative half pi. It doesn't matter if it starts from 0, so long as it repeats itself every 180 degrees. So what I mean is this. Right? And then we know this is pi. This is 0. Okay. So this is my personal preference, how to use this graph help you. Okay, say from each graph, we know within 360 degrees it repeats itself. So if I know, let's say, sine 30 degrees is 1/2, and I definitely know if I plus by another 2 pi, which is plus another 360, so we know 390 degrees sine is also 1/2. And I will also know if I plus another 360, that will be 750 degrees. This is also 1/2. Right? I hope this makes sense. So if you plus in 2 pi, it will give you exactly the same value. That's what period means. So for tangent, it's the same thing. Let's say tangent quarter pi. You should be able to know what this is. This is 45 degrees. Tangent 45 degrees is 1. So I know if I plus another 180 degree or a plus pi, this is also equal to 1, right? And on and on and on, right? So this is the first effect. First effect. So plusing or minusing a period by period gives the same result, same trig ratio, right? And then there is another effect, what we call principal solution. Principal solutions, right? So there are other solutions that are not in 360 degrees more or 180 degree more, not linked by the period. So for every type of function, there are two, right? So what we mean is by sine theta, we have, for example, sine 30 equals to sine 180 minus 30, which is equal to sine 150. How do I know that? This is from the symmetrical property of sine. If you look at the sine graph, right? Although it only repeats every 360 degrees, but within the 360 degrees, you say if I draw a line, right? You say two values. They are symmetrical. So this is 180 degrees. So it's either this nut value or 180 minus this value to represent the symmetrical. And those two solutions are what we call principal solutions of sine. And then we have another set of principal solutions for cosine theta. Cosine theta is, so the principal solutions or cosine, let's say cosine 60 degrees. This equals to cosine negative 60 degrees, right? So cosine, if we plus another 360, so cosine 300 degrees. Negative 60 plus 360 is 300. We're plusing a period, it doesn't change the value, right? So what we actually mean by looking back at the graph is that if we extend to the negative territory, we say it's very symmetrical. So a positive value will equal to a negative value, right? So if I draw a line here, a positive degree versus a negative degree, they give the same cosine value, right? And then, of course, a negative value, you can plus 360 to give you this, right? So within a period, it's this and this, right? But I normally remember it as using a negative value. And tangent theta, right? Tangent theta, you also have a principal solution, right? So for example, no, tangent theta, you only have one solution, right? Only has one solution. And then you're just adding 180, right? Adding 180 to get more solutions. So I summarize this in a formula. So sine theta equals to sine 180 minus theta. Cos theta equals to cos negative theta. This is the preferred way of working out a solution set of sine equation. Let's see how this connects to this one, right? We know sine theta is sine theta 180 minus theta, right? That's exactly why the sine theta in the second quadrant is positive, because we're essentially talking about a symmetrical solution of sine, right? And when talking about cosine theta, right, you say cosine 60 is cosine 300. This is what I mean. So this is all positive. Cosine 60 is cosine 300, right? So still 60 and versus negative 60 degrees, or 300 degrees, if you prefer to call it, right? So those are two principal solutions. But as you say, for sine and cosine, the solutions are in pairs. For tangent, let's see why this is the case. So let's say tangent 60. We know adding 180 will make the same tangent because it's the period. So that means, so this is 240 degrees. This is also another solution, right? So in other words, you can think in 360 degrees, sine, cosine, tangent, they all have two solutions, right? For sine and cosine in particular, they have special twin solutions, and we call them principal solutions. So after we explained the framework, okay, so we have to go back. Remember this cost thing, right? Remember this cost thing, CAST. Then we're gonna look at these questions. Question number 8. Solve sine x equal to 0.1. Sine x equal to 0.1. Right, so sine x equals to 0.1. Remember, we're solving between 0 to x, between 0 and 360 degrees. This is very important because, as you see, if I don't limit the domain, I can end up with as many solutions as I can by adding 360 degrees to the solution. Okay, I'll show this a bit later what I mean. Right, sine x equal to 0.1. And also, you have to be comfortably realize, I can alternatively write 0 to 2 pi. This will depend what degree system you will use in your solution. If they use pi, your solution must also be in pi and radian. Right, so sine x equal to 0.1. This is an easy question. In IG, you would solve x equal to x equal to sine inverse 0.1, right? And then you just press a calculator, right? Sine inverse. Sine inverse. Okay, so sine inverse sine degree trigonometry. Sine inverse. Let's try. See what? Okay, I'll grab a calculator. So if you press a sine inverse, the answer will give you sine inverse. The answer will give you 5.73 degrees. That's 5.74 degrees. Okay, now this is only one solution. We can get its twin solution by using what? Remember the CAST thing? So this is a sign, right? So sign is positive here, it's also positive here. And remember its twin solution is 180 degrees minus 5.74 is another solution. So 174.26 as in the other solution. Remember for sine graph, it only has two solutions within 0 to 360. Graphically speaking, it means this. From 0, this is pi, to pi. Sine x equal to 0.1. We have one solution, we have another solution. Done, right? So this is the first question. The second equation, right, it's cosine x equal to 0.5. Pretty much the same thing. Cosine x equal to 0.5. I directly know the answer because why? This is a special angle. We know x equals to 30 degrees. All right, you can press the calculator. Let me just press it. Cosine 0.5. This is 60 degrees, right? 60 degrees. Okay, so this is a special angle. You need to remember, right? And then x equals 60 degrees, and it's twin solution, right? Remember this. The twin solution is CAST, right? Remember, cosine is positive here. So we are looking at these two. So this is 60, this is also 60. So we are looking at or 300. Right? I hope this makes sense. Graphically speaking, right? What does it look like on graph? Does it look like on graph? So it looks like this, right? So this is 0, half pi. This is 2 pi, and this is pi. 60, so 0.5. Right, that's not very accurate. So we're looking at this one here and this one here. All right, 60 and 300. The next question, tangent x equal to -2. That's the same thing. All right, so this one you have to press the calculator. Tangent inverse -2. is negative 63.43. Now, this solution is not inside the domain, so it's not even part of the answer. But then we use it to get the solution because we can plus 180. Right? So 63.43 plus 180 is 106.57 degrees. This is only one of it, right? You can also plus another 180. It's 296.57 degrees. Okay, so using the CST, what this means, we are looking at one here and one here. But then this is a negative, right? We're looking at positive here, but then looking negative, it must be here and here. Right? So that means this is 116 and also 296. I hope it makes sense, right? And then graphically speaking, this, some people might ask, why do we press the calculator and end up with a negative degree? Okay, so this is why, right? Remember, we have to calculate x as tangent inverse negative 2. This is an inverse function, means you can only find the inverse function if it's one-to-one function, right? We learned about that in function. But if we look at a tangent graph, if we only plot the positive, this is, you have a disjoint point. That is the reason why we don't like it. So we define the one-to-one function to be this. So this is for the inverse. So this is a very connected, we call it continuous function, so that we don't contain an asymptote, right? So and then this is a negative 63. We got this solution, but then that's not what we want. You actually want here, right? So that's 100, right? And then another, right? So it's these two solutions. This is pi, this is 2 pi. I hope this makes some sense. So you might ask, why are we doing this complicated? This is trigonometry. You have to be able to see trig functions from different perspective, right? This is from the unit circle perspective because I'm imagining a triangle, right? This is from the graphical perspective, and then visualizing the graph of trig functions. And there is indeed an algebraic aspect of it, right? So you have to realize 180 minus x will give you the same sign value. And you have to use positive and negative sign angles, you can get the same cosine value. So the next question, this is the same thing. Right, let's just move on to question number 5. Sine square x equals to sine square x equals 1 minus cosine x. Right, so this is the point where we need to use trig functions, or trig identities. You see, it's a sine square and cosine. We are not able to solve this if you see a mixture of all trig functions. Right, they are different function types. How can we unify them? How can we make them all in terms of sine or all in terms of cosine? We say we only have two identities. Do you still remember the two identities? We have sine square x plus cosine square x equals 1. We have tangent x equals to sine x over cosine x. At AS, these are the only two identities you need to worry about. So by the look of it, which one do we need to use? It's very obvious that we need to use the first one because it contains a sine square, right? This first one allows us to convert between sine and cosine. Right? The second one also do the same thing. It can turn between sine, cosine, and tangent. Right? So this is the only situation to know, right? So you change this into 1 minus cosine squared x equals to 1 minus cosine x. You see, now it's a unified equation with involving only cosine squared x. We rearrange into general form, right? You should be able to see this is a disguised quadratic. So cosine squared x minus cosine x equals 0, right? This is a quadratic. You see something squared minus something. So x squared minus x equals 0. How to solve it? This is a one tricky stuff. You can factorize it, but you cannot divide both sides by sine cosine x. Okay, so we do this way, and then you know one solution is cosine x, because this is why? Because this is cosine x minus 0, cosine x minus 1, right? So cosine x equals 0 or cosine x equals 1. From cosine x equals 0, this is a special value, right? I hope you still remember the cosine graph. Cosine x equals to 0, we have the value is 1, right? But cosine x equal to 0, so we are looking at this point. This point is half pi, right? So we know x equals to half pi. What is its twin solution? What is the other principal solution? It's minus half pi, or 360 minus half pi, 270. We shouldn't be using half pi. We should use 90 degrees and 270 degrees, right? 270 degrees we mean here. This is 90. This is 270. But that's the solutions of cosine x equal to 0 in those interval. And cosine x equal to 1, you see it's 0, right? And then 360, right? 0 and the 360. So 0, 360. I hope it makes sense, right? Uh, Remember, we can also add the 360 to any of these. We can add 720 to any of these to form another solution, but we are only solving within 0 to 360. So these are the solutions. Okay, and also the next question. Sine square x equals 1. Sine square x equals 1, right? So this is a quadratic equation by itself. Something square equals 1. What do? You're taking square root on both sides, but don't forget the plus and minus. So that means sine x equals 1 or sine x equals negative 1. So at this stage, you should be able to see the answer directly. This is special value. When does sine x equal to 1? When it's half pi, right? So x equals half pi. And it has another solution. Does it have another solution? Is 180 minus half pi. So this just means the twin solution is exactly the same. So we only write 1. You see what I'm doing? I'm using, oh no, okay, sorry, not using half pi, using 90 degree. So it's 90 degree. So the other twin solution is 180 minus 90 is also 90. So they have repeated principal solutions, right? So we just only write 1. 90. Sine x equal to negative 1, right? You see? This is what is this? This is 270. 270 degrees, right? Remember, it also has a twin solution, right? So its twin solution is the same. It's what? Let's just calculate 180 minus 270. This is its twin solution, which is a negative answer, negative 90. Whenever you get a negative degree, you plus 360, right? To get to its solution in the positive territory, so 270 degrees. You see, its principal solution is still 270 degrees. Doesn't make any difference, right? So that explains. So that's why I prefer using this graphical method rather than the CAST method. But it's definitely more people use the CAST method. It's up to you. So I mean, these are the only two solutions. Next, let's say 1 minus cosine squared equals 2 sine x. Again, here you have to use what? The trig identities, changing the cosine square into sine square, and that's a disguised quadratic. Here, it's the same thing again, changing cosine to sine. However, you can do it another way, right? You can either change it to sine, and then that's a quadratic equation, which is I prefer, or you can move the cosine square to the other side, and it changes to okay. Let's do this question. Changes to tangent. Sine square x equals to 2 cos square x. If you divide both sides by cos square x, so it becomes sine square x over cos square x equals to 2. You see, this thing is sine x over cos x squared equals 2. And this, we realize, it's tangent x. So tangent square x equals 2. Tangent x equals to positive minus 2. All right? Using the Presto calculator, we know tangent x equal to 2, tangent x equal to negative 2. They both, they have solutions 63.43. And then you plus another 180, you have 243.43. Whereas negative 2, so it's negative 63.43, you plus 180, you end up with 106.56, plus another 180, you end up with 296.57. These are the four solutions. Okay, all I'm using is the knowledge of period and the principal solutions, right? This is pretty much the same thing. This is a disguised quadratic, right? You see square and then minus tangent x. So that's by itself. You can solve it and then solve the tangent. This is the same thing. You change, use the trig identity, change cosine square x into cosine. And then you're solving a disguised quadratic in terms of cosine, right? So I hope this explains some of your questions, right? Thank you.